When I first got into this, I was concerned that we would be considered the Darth Vader, or the enemy of the concrete industry. And what I've found is that there are a large amount of producers and people in the industry and companies in the industry that know that the current way of making cement and concrete is not sustainable.
Hey, Erum, how's it going?
It's going. How are you doing, Karl?
Pretty good. Last week was a pretty wild week, don't you think?
Yes, it was super wild. We had a good time at Ferment. How did you like it?
So just by way of background, we were at Ginkgo Ferment. Ginkgo Bioworks holds an annual event where they showcase their progress in biotech. And then they also let many of the companies that are associated or have spun out of Ginkgo come up and give us a preview of what they're working on. And I thought it was actually pretty exciting. Number one, we got a recap of all the exciting things that happened in 2022 with biotechnology. The most notable one is that the US government, particularly the White House, are taking biotech and biomanufacturing very seriously. And there have been some significant investments being made in that. So that to me was the highlight of 2022. But there were a lot of other things. And then Ginkgo showcased their platform. And one of the things that I thought was very interesting and shows the confidence that they feel in the work that they're doing is that they are willing to do pricing based on success. A company can go to them and Ginkgo won't charge them unless they're successful at, let's say, engineering a strain or developing an enzyme. So I found that to be really interesting. I don't think anybody else in biotech has done that. It's very bold. Now we just have to see who goes into it and how they use that platform that way. What did you think, Erum?
Yeah, that was my first time going to Ferment. I've been to tech conferences and I've been to chemistry conferences. I think Ginkgo is on the tech side in terms of the conference experience, where there's a lot of showmanship, there's a lot of performance. It's very exciting. It's very Steve Jobs, Apple, big reveal, one more thing type of content, TED Talk style, where the American Chemical Society is a little bit more dry and academic, let's just say that. So they definitely pulled out all the stops. It was great to hear about all of the progress across the board for a lot of their companies. We heard from our friend Nicole of Alonia, Jasmina of Archaea. We saw Cass from Ginkgo, who just had a little baby. So it was good to see his little baby. And congrats on that. And Megan Palmer, who also joined Ginkgo after we spoke with her, not because we spoke with her, but it was just a coincidence that she is now a part of their team. So it's good to catch up with her. So a lot of people from the Ginkgoverse have been a part of our podcast, and I'm sure there'll be more to come.
Yeah, the other thing, always these conferences, what's great is to meet up with friends and to meet new people. We're talking about people that we know that have been on the podcast. We spent some time with Suzanne Lee of Biofabricate. Amanda Parks was there. So that was very nice. Our friend Spiro of Cell Signaling was there, and it'd been a while since I talked to Spiro. And then our friends of Cultivarium were also there, and I was excited for them to be there. We spent a good amount of time with them. And then we were lucky enough to go to Alonia's lab opening the next day. So it was all good. If I forgot anybody, I'm just thinking of Natalie Kudel. It was really great to see everybody in person. And given that next month we'll be going to SynBioBeta, we're going to see a lot of those people, but then a whole other set of people that we know, and we'll meet a whole other set of people. To me, the biggest takeaway is people are very optimistic, even though biotech has been in a winter. And we just see that the number of applications continues to grow. We're seeing biotech applied in places that are very surprising.
When we were at Ginkgo, we saw a lot of our listeners, and I felt like a little celebrity because they're like, oh, wait, not that they just recognized me because we don't have a lot of video content out there right now. When I tell them, like, yeah, I work with Karl at Messaging Lab. We have this podcast called Grow Everything. They're like, you guys are the Grow Everything people? And I was like, yeah. I'm sure that this is how Neil deGrasse Tyson feels, although he's known way more than just the Star Talk podcast. He's done so much, like his show Cosmos, and he appears on TV. He is that astrophysicist celebrity that we all love. But one thing, I've been listening to Star Talk a little bit more. I think they are one of the more exciting podcasts in terms of the production, the topics. But Neil has been talking a lot about biology lately on his podcast, and maybe not lately because like I listen to Star Talk on shuffle sometime, depending on where I'm listening to Star Talk, whether it's on my phone or through my Alexa device. He's covered topics across genetic testing, longevity, human augmentation, and I'm like, cool, great, Neil, this is awesome. But I'm like, stay in your lane, Neil. Biology, that's Karl and Erum's gig. That's Grow
Well, and
Everything.
it goes back to what we were saying, that there is no biotech celebrity yet, but I'm sure that person is going to appear, and it might be someone we know, maybe someone who has already been on this podcast. And there is a lot of opportunity for that to happen, given the impact that this industry is having on people's everyday life. I'll use that to segue into this conversation that we're about to have with Loren Burnett, Prometheus Materials. Prometheus is developing a type of concrete, and I'm excited to have him on because this is probably one of the most radical applications of biotech that we've seen that has potentially tremendous impact, given that cement is something like in the top 3 or 4 polluters on the planet.
Yeah, so let's let Lauren take it away.
Hey, Lauren, thanks for taking the time to speak with us today. Welcome to Grow Everything.
Thank you very much for having me.
We are excited to be talking to you about Prometheus Materials. But before we get into that, I was hoping if you could give us some background on yourself. How did you end up at Prometheus?
Sure. I'm a serial entrepreneur. I've started and raised, this is now my 6th company in technology that I've started. I'm a serial entrepreneur that just loves starting companies and taking them all the way through to a successful outcome. It was during COVID back in February of 2021. We were all at home using Zooms and not meeting in person. And I got a call from the technology transfer folks at the University of Colorado, who I've known for a long time. And they said, hey, we've got this technology that we're about to spin out for licensing. Are you interested in taking a look at it? And I was sitting at home. I was bored. I was ready to do anything. So, of course, I said yes. Met with the professors who were handling the project at Colorado, and they mentioned a couple of things. They mentioned what they were doing, what the technology was, what the industry was that they were working in, and the fact that this had been through a Department of Defense contract, which is where the technology started. And that had gone on for 5 years and had successfully completed that. To me, that became not only interesting, but also that was a big part of due diligence right there. If DoD signed off on a 5-year project, then I'm interested. I researched concrete and realized that this was an opportunity to address a very large problem in a very large industry and to potentially make a difference to the world. And that's very exciting to me. We continued our conversations and I ended up joining on with the 4 professors. And by March of that same year, a month later, even though we had never met in person, the 5 of us co-founded Prometheus Materials.
What exactly is Prometheus Materials?
So what we're doing is we're using biology, and we're using natural microalgae, no GMO or anything like that, the type of algae that you'd find in a lake or an ocean or even maybe on the side of your fish tank. And we're stimulating a natural process called biomineralization. And biomineralization is using biology to create minerals. And in our case, the mineral that we're creating is calcium carbonate. So what we're doing is we're stimulating algae to biomineralize calcium carbonate on a commercially viable timescale and volume levels. We're then taking that algae and the biomineralized calcium carbonate, combining it with a couple of other things, natural binders and some other things, to effectively create a virtually zero carbon alternative to traditional Portland cement. We then mix that with aggregate and sand, and we have a virtual zero carbon bioconcrete.
Wow, it's fascinating. That's amazing. But what about the concrete industry do you think it's important to create a concrete alternative? What's going on in the concrete industry today where this is important?
Concrete is an amazing thing. If you look around, it is literally everywhere. It's in blocks, it's in sidewalks, it's in buildings. It is all over the place and in very large volumes. So the problem with concrete is it's very dirty from a CO2 perspective. A couple of facts. Concrete is responsible for 8% of the CO2 emissions on Earth on an annual basis. 8% for one product is huge. That's more than automobiles, for instance. It's also responsible for using 9% of Earth's industrial water production on an annual basis. We're out here in Colorado, and most years we're in a drought situation here. So water is becoming very precious, and concrete utilizes a huge amount of water. So the problem is very large and very dirty from a CO2 perspective, but it's actually much worse than that because building space is forecasted to double between now and 2060 worldwide. So if you think of the amount of concrete required to double building space globally, it's enormous. That's the equivalent of building a new New York City every week for the next 36 years. So that's the problem that we are working to solve. If we're going to meet the COP26 objectives for CO2 emissions by 2030 and then net zero by 2050, there is no way that we can possibly meet those without making a serious change to the CO2 production based upon concrete.
Now, I'm curious about your products. Erum and I are both based in Brooklyn, and we see buildings going up all the time. And part of watching these multi-story buildings go up is the days when the concrete trucks pull up in a line, and then they've got these concrete pumping frames that they use to lay the foundation, lay the beams, and then build the floors one upon the other. Does your product allow for that kind of building as well? Does it work in the same way?
So right now, we are focused on precast concrete products, bioconcrete products. So things like blocks, flat panels, all sorts of precast items are out there today, literally thousands. What you're talking about is ready mix, where you've got the truck that's spinning around and it's pumping the concrete and that gets sent up to the 50th floor to work on the building. We are not doing ready mix yet. That is on our product development plan. But right now we are focused on precast concrete items.
I wanted to understand a bit more about the precast. How is that being used in the industry today? What part of the building or other infrastructure is precast being used?
There's an amazing amount and variety of precast items that you see every day. We just don't really think about them as being precast. In building construction, there are lots of components that are structural components that are precast. You don't need to reinvent the wheel every time in a specific building. You can use precast items for floor support, roof trusses, all sorts of different things. There's precast items in all of the infrastructure. So for instance, water mains. Water mains might be precast, or sewer conduits can be precast concrete. It is literally everywhere. Also, flat panels is a classic thing that is precast. So there are lots of different types of precast products that are out there today. And there's a lot that we will be focused on in terms of our zero carbon alternative to the currently carbon intensive precast items.
One of the items you mentioned is a flat panel. For example, I remember reading an article not too long ago that said that all buildings are turning into car dealerships, meaning that you can build a building a lot faster because of how modular they are. And when you start to look around at buildings, you do realize that there is a lot of these, I believe, you tell me if I'm wrong, concrete flat panels that are put as walls on the outside. That's what you're talking about.
That's one of the things I'm talking about. So those are commonly called tilt-up walls.
Yeah.
They cast them in place and then basically just literally with a crane tilt it up and you've got an erected wall.
So in terms of performance characteristics of bioconcrete versus traditional concrete, is there any difference at all, or is it the same?
So what's important to keep in mind is that we are not traditional cement and concrete. We are a completely different material. That has a lot of importance in terms of answering your question. So we have a lot of the same capabilities and characteristics of concrete today in terms of compressive strength and other things. But we also have a lot of capabilities that concrete doesn't have because, again, we're a different material. For instance, our tensile strength, which is that ability to bend, and believe it or not, concrete does bend. We are about 5 to 10 times stronger from a tensile strength perspective than traditional concrete.
Oh, wow.
We have capabilities such as sound attenuation. When you make concrete, you basically are creating a ceramic, and that ceramic reflects energy. So whether it's sound energy or other types of energy, it basically gets reflected. And we don't create a ceramic. What we create is a kind of a lattice network of connections between all the various sand particles and aggregate particles in our mix. And so when energy hits our product, instead of going straight in and then reflecting back out, we dissipate and go 1,000 different directions inside our material. And so what that does is that has the capability to dissipate sound as opposed to reflecting it. Some other capabilities that it creates is, because of this network and this matrix of connections, it creates countless microscopic spaces within the material. And what that does is that enables us to have 90% less thermal conductivity than concrete does. What that translates to is that translates into basically our material, instead of transmitting cold or heat from the outside, we actually provide our insulation factor, which is very different. Also, blast resistance. All of this comes back to the same thing, which is energy and how we deal with energy. So blast resistance, as I mentioned, we came out of the Department of Defense back in the 2016 to 2021 timeframe. And at the end of the project, they sent our technology to an Army lab to do testing. And they shot things like 50 caliber projectiles at it and simulated shrapnel from bombs and so forth. And we, of course, could only see the unclassified version. But what came back was that they had never seen a material act like ours did. Because whereas concrete might create a crack, which is a fairly linear crack through it, what we do is we, again, are just dissipating that energy throughout our material. And so we create a blast resistance, which is very similar to what we're doing with sound dissipation and thermal conductivity.
That's
Wow.
amazing.
Yeah, mind blown, no pun intended, but
Yeah.
that's amazing.
Sounds like the performance characteristics will give engineers, I'll say, a run for their money, but really what I mean is they're going to have to rethink how they're engineering. For example, when you're talking about sound, I was just imagining, what does a music hall look like when it's built with your material? Because so much sound engineering goes into speaker placement, and the seat and all that stuff is placed just because all of those things impact the sound that you're listening to. And so I would imagine any application of your bioconcrete in those kinds of settings will require rethinking how that is engineered.
No question, and how it's architected as well. In fact, we were talking to an architect who's building an outdoor amphitheater, and the back wall has to be sound engineered. You can't be reflecting sound on the back wall of the stage. And he was lamenting how much work has to go into building a back wall that has sound attenuation capabilities. You've got the structural part, which may be concrete, but as we know, concrete's just reflects sound, so that's not good. And then you've got to build effectively 7 layers of different materials to create the sound dampening effect. Each one of those has a materials cost and has a services cost to put it together. And his comment was, if we could use your material to effectively do all of that with one component, that would be huge.
We need something to create a podcast studio.
Yeah, I was just thinking of recording studios.
That would be amazing. So this is from a calcium carbonate, something that is found in the seas. How do you find this in nature?
The closest analogy would be how nature creates seashells and coral reefs. So that's using biomineralization to create calcium carbonate. And as we know, coral reefs and seashells last for hundreds, if not thousands of years. They're conch shells that they have from over in Rome going back to 2,000 years ago.
Yeah.
Time scales. Nature's very smart. Nature does a great job of doing these types of things. And what we're learning is how to harness nature, to use nature to effectively help cure some man-made problems, which is CO2 pollution to the atmosphere.
And what does production look like for this product? Is it big steel vats? I have no picture of what it looks like.
Behind these doors that you see behind my head here is our biotech manufacturing facility, as well as our bioconcrete block manufacturing facility. Right now, we are at a pilot scale, so we're creating demonstration quantities. But on the bio side, what we're using photobioreactors, which are basically big containers where you can contain fluid. And in our case, we're containing a medium in which we grow the algae. And so these bioreactors have LED lights surrounding them, which mimic sunlight. And we're basically just bubbling up ambient air from outside into the bottom of these tanks, and that becomes the CO2 source. Then we have algae. That algae uses basically photosynthesis to grow. It's utilizing that artificial sunlight as well as the calcium and other nutrients in the medium and the carbon dioxide to grow and reproduce. And in our case, the algae, it's pretty amazing. Algae in general is pretty amazing. Yeah. You can make so many things with algae. I mean, if you think back to the biofuels industry, you could make diesel, you could potentially make gasoline. There's a lot of things you can do with algae. And in our case, we're ultimately making bioconcrete with algae. But the algae that we're using is able to reproduce itself every 4 to 6 hours under certain conditions. So it's very productive and very prolific. And then what we do is we then harvest the algae. We stimulate biomineralization through some secret sauce that we have. And that biomineralization then causes that algae to stimulate the production of calcium carbonate. We then are able to take that algae material and the calcium carbonate and put that in with some natural binders to create a zero carbon biocement.
Love that. We are no strangers to algae on this podcast. We've had Checker Spot, so the polyurethane from algae.
Sure.
Spira, they've created dyes from algae. And I think they're just creating some food ingredients as well. And I think there might have been some others, but we love algae over here at Grow Everything.
Lauren, if you could tell us, you said the current facility is pilot scale. What does it look like when it's production scale? And is that something you guys are thinking about distributing that kind of manufacturing to different parts of the country or different part of the world? Or what does that look like?
The algae part that I just described is the front end. The back end of that, if you will, is taking that zero carbon biocement, mixing it with sand and other aggregate in just traditional standard concrete type of material and tools. That drops into molds to create bioconcrete masonry units. You might call those cinder blocks or concrete blocks, or if you're in the UK, you might call them breeze blocks. Basically, that's just a very, very standard building material that's used in quantities of literally hundreds of billions worldwide every year. And so that machine then takes that mix, it condenses it, compresses it into a firm block, demolds, and that block then goes into a drying chamber and dries at just ambient temperature and ambient pressure, not using virtually any CO2 or power to make that happen. That's how we do it today. The whole back end of that I described is basically just using standard concrete block making equipment that's out there today. But we're pilot scale. This is for demonstration purposes. This is not something that you would build a large data center out of today. But we are in the process of raising our Series B round of funding. And one of the uses of proceeds of that will be to build a full-scale production facility, which will produce quantities that you can build major things out of. We'll have 4 different lines, one of which will be the bio-CMUs, the blocks, but then we'll be producing other things that we're looking at right now and evaluating. It might be the flat panels, it might be the sound attenuation, it might be other things that we're taking a look at. And those will be produced in high volumes, again, using just standard concrete production equipment. So we'll continue to grow the algae here using photobioreactors, and we can just continue to add that capacity as we need to, and then provide that material over to the production folks that are making the concrete precast products.
It almost sounds like you could take those photobioreactors and put them into or next to any facility that's already producing any of these concrete products that we've talked about. Is that the case, or am I not understanding?
You've got a very good understanding of it. I'm going to tweak what you said a little bit, though. Our ultimate move here is not to produce our own precast products, but it's to license our capability to large-scale producers of cement, concrete, and precast concrete products worldwide. Our ultimate goal here is to reduce CO2 to the atmosphere by a gigaton per year. That's a very large amount of CO2. We're not going to do that by ourselves, and we're not going to do it tomorrow or next week, but we will do it by licensing our technology to those large organizations that can produce and distribute our material worldwide and basically use that to replace high carbon intensity concrete today. And so we will continue to make the algae and then ship that to licensees to produce the products.
So the concrete industry is your customer, pretty much. Is that how it's working?
They are, absolutely.
Yeah.
You know, when I first got into this, I was concerned that we would be considered the Darth Vader or the enemy of the concrete industry. industry. And what I've found is that there are a large amount of producers and people in the industry and companies in the industry that know that the current way of making cement and concrete is not sustainable. We can't keep producing 8% CO2 emissions and be sustainable through 2030 and 2050. It can't happen. It can't be allowed to happen, I should say. So what you see is you see a lot of companies that are addressing this problem. And this problem, it's very large. They're working with the supply side. So they're working with makers of cement and concrete, cement being one of the two major components of concrete. And they're working with those to reduce the carbon footprint of cement and concrete, which is great. We need everybody to succeed here to get to where we need to be globally. But oftentimes, those technologies are starting out working with traditional Portland cement, which is the vast majority of cement that's out there today, and then doing things to it, like adding CO2 or doing other things. And we're not starting with traditional Portland cement at all. We are taking a completely different approach, and we are able to basically eliminate 100% of CO2 from concrete. And that's a big difference.
That's wonderful that you're supporting this big industry, that they are aware that there needs to be change and that you can help them reduce their carbon footprint. And earlier you mentioned you're at a pilot stage and you're not ready to make data centers, but you're going to get there. And one of the questions I have here was, you have some big companies backing you, like Microsoft and Autodesk. And at first, when I first saw that, I'm like, I wonder why they're supporting this bioconcrete company. Now I get it. They need data centers. That's how they operate. Can you tell us a little bit more about these companies that are backing you now?
Sure. And by the way, we are absolutely thrilled and delighted and honored to have companies like SOM and Microsoft, Autodesk, GAF as partners. And not only are they strategic partners for us, but they also invested in our Series A, which I think speaks volumes for what they think of what we're doing here. I mentioned that most of the other companies that are trying to reduce the CO2 footprint of concrete are working with the suppliers. We are taking an entirely different approach. We are working with the demand side. So specifically, companies that specify the use of large amounts of concrete, such as the architectural, engineering, and construction companies like SOM. Of course, SOM's the architect of the world's tallest building, the Burj Khalifa over in Dubai, as well as One World Trade Center in New York and many other notable buildings. And they specify enormous amounts of concrete. And they know that that is not sustainable going forward. That's got to change. So the folks that specify, companies that use large amounts of concrete. For instance, Microsoft is producing 50 to 100 data centers every year. And these aren't just data center buildings, these are data center campuses. And if you think about what a data center looks like or is, it is basically made out of steel, concrete, electrical capability, and air conditioning and communications. Those are the big components. Lots of concrete. So we're focused on working with companies that use lots of concrete in their processes, such as Microsoft, and then companies that use concrete in products. And for instance, GAF and their sister company, BMI, together make the largest roofing materials company in the world. And that includes the use of large amounts of concrete. And so we've brought companies that represent each one of those three areas in as our strategic partners and investors. And then Autodesk Foundation, they are heavily involved in sustainability. And Autodesk is the go-to software in enormous number of companies worldwide. So we are absolutely delighted to have all four of those companies as our partners and investors.
Yeah, that should help you with the Series B too. They have those big names in the Series A, hopefully.
Certainly doesn't hurt, that's for sure.
You've talked a lot about the concrete industry. What does it look like? I would imagine there's a concrete trade show and you guys are there. What's the reaction from other people in the industry? It's like you said, you thought that you were going to be the Darth Vader in this industry, but it sounds like the reaction has been very positive.
It overall has been very positive. We were at the ACI conference last week in San Francisco. It's the American Concrete Institute. And we exhibited there. First of all, people didn't know that we existed and this technology existed. And there we were in the heart of real concrete folks. And we had lots of folks come up that were very interested and very excited because many of those companies and leaders realize, again, that the current technology is not sustainable. So we offer an opportunity not to do away with their business, but to enable their business to extend and be sustainable. For us, we see ourselves as being a very positive and new capability for those companies, not a company that's looking to cause problems or damage.
So you said you were at the American Concrete Institute trade show. Were there any other companies that were displaying biological solutions?
No. It's interesting. We'll also be exhibiting at UK Construction Week in London here in another couple of weeks, and then at the American Institute of Architects A23 conference in San Francisco in June. And I attended both of those conferences last year, and there was virtually no mention on the floor by companies exhibiting of sustainability and carbon reduction. Now, when you go to all of the different classes and all of the different presentations, lots of talk about it, which is great, but very few companies actually delivering product. And we are actually delivering product, and we're very excited about that.
Yeah, the one company that we had known, and we know them for Biofabricate, is Biomason, but I think they're very different from you.
We don't look at anybody as a competitor. And I don't say that from an arrogance perspective. That's not what I'm saying. There's so much concrete and there's such a CO2 problem. This is not a zero-sum game. We all need to succeed. And this is big enough where we all can be wildly successful. And that's the way that ultimately we will experience large reductions in CO2 on a worldwide basis.
Yeah, one of the things I say, Erum has heard me say it many times, is we need every solution everywhere all at once. And you guys are definitely part of that solution.
You said it very well. We need to all be successful, and we can all be successful. The market is large enough and the problem is large enough for that to be the case. There's a lot going on in biotech, a lot of new stuff that frankly hasn't been thought of before. Now we collectively have the technology to bring that to fruition. I think you're going to see a lot of very exciting things come out of biotechnology over the next decade. It's really an exciting time. This is where nature comes back, and we're able to help harness nature to solve global problems. And it's very, very exciting.
Yeah, that's great, Lauren. Is there anything that we should have asked you that we didn't ask? Or is there something that you wish people would ask you that they don't ask you?
That's a great question. There's so many thoughts that come to mind. I think that overall, focusing on CO2 reduction and using biology to help make that a reality is something that people are learning about and haven't really been very focused on in the past en masse. And I think that's starting to change. Just the people that would come up to us at the show last week at ACI, that they get that kind of quizzical look on their face. They say, "You're using algae to create concrete? How does that work?" And when you explain it to them, and then when you make an analogy to seashells and coral reefs, you can see that things start to click. And that's just one of potentially millions of opportunities for bio and biotechnology to make a difference in the world in a very positive way. We're thrilled to be part of that. We're thrilled to be upfront in that from a climate perspective. And our mission overall is, as we deliver these products and deliver very large scale reduction in greenhouse gases, we'll be looking to biotech to create new products that frankly none of us have even thought of before. And that's where we are looking to go on a long-term basis here. We think there's just a phenomenal opportunity, and the future is actually very bright.
That's wonderful. Thank you so much. Congratulations to you and your team for building this incredible company and contributing to the bioeconomy. It's very impressive. We're excited to see you complete your Series B and grow the company, take it to the moon. Like literally, if you can, take Prometheus Materials to the moon and build some infrastructure there. We'd be really excited to see that.
Yeah, thank you so much, Lauren. This interview was a joy. It's like we haven't had any construction people on yet, so I'm really thrilled that you are the first, because I love the mission and I love what you guys are doing. Your progress is very inspiring.
Thank you very much for having me, and just keep watching us. We're on a mission to change the world here.
Excellent. Thank you so much.
Thank you.
Erum, what did you think of that interview?
You know what I'm going to say, Karl? I'm going to say that was freaking amazing. Can you believe what they're doing? So one thing, let's just start from this very important concept when we're talking about biomaterials, is that when I asked him about how the concrete industry sees their concrete, he was quick to respond is that they're not making concrete, right? It's not concrete. It's a new material with different performance characteristics. And this has been happening as we talk to other biomaterials company, maybe other people in the media are calling their company like an alternative leather, but the founders of the company saying that it's not leather. It's a completely new material with different characteristics. So it's going to be interesting to see how people are describing their materials, right? On Prometheus Materials website, they talk about a biocomposite, which is great, and I think that's helpful. But what are those new words? Concrete had to be created from a word. I haven't done the
Etymology.
taxonomy on the
Yeah.
etymology of the word, but even leather was a word that was created to describe that material. What are these new words that are going to come up to talk about these materials? So I thought that was very exciting. What about you?
So just a little bit of a backstory. We were introduced to Loren and Prometheus by our friends in France at Sophie Nova, which is a big investment firm in France. One division focuses on industrial biotechnology. And we've done a bit of work with a couple of the companies. So full disclosure, a couple of the companies that are in that portfolio, we've not worked with Prometheus. But Josco, the lead investor, invited us to introduce ourselves to Loren and the team. And I am so impressed by what they're doing. The only other company that I know that is using biotechnology to produce a building material, well, two of them, Ecovative, who will be on the podcast very soon, is doing building materials, and then Biomason, which is growing bricks. And people are always amazed when we tell those stories of these companies that are doing that. Now, in the case of Prometheus, as you said, the performance characteristics of the material, of this new material, to me were amazing. The fact that it absorbs sound, it absorbs heat. Like I didn't know that cement does not absorb heat. And then the climate change implications are just stunning. I mentioned it at the intro, cement actually accounts for something like 8% of all the world's carbon dioxide emissions. And clearly Prometheus is doing something correct because of the reaction that Loren mentioned they got when they went to the cement meeting, is all I'm going to call it, the American Cement meeting, which is amazing to me that there is a meeting that is dedicated to cement, but nothing surprises me anymore.
One of the performance characteristics that I think is very important to talk about is the absorption of sound.
Yes.
That was very interesting to me. It sounds like the material they're making is the same material that is made of seashells and coral. That's so fascinating because could you imagine like living in this big seashell, like this big conch shell, and that's your home or an amphitheater? Like now we're talking about like Fern Gully level, like life, truly like living in a world where it's made of plants and seashells. If you look at our website, messaginglab.com/grow everything, like you'll see an image there, and it's like of this like futuristic city that has very creative looking buildings. It's a Mid-Journey image. And it also reminds me of an architect that I loved, and God rest her soul, she had passed away, Zaha Hadid. Do you know her, Karl?
Yes, her buildings are stunning, but I do know her very well. I know her work very well.
Zaha Hadid has made some beautiful buildings and structures like bridges. And then she has, of course, a lot of beautiful renderings. And a lot of her architecture is very organic looking, beautiful. It's like wide, where in contrast to a lot of architecture, it's very phallic. It's just tall. That's
Right.
it. Where hers is like very like wide and flowy and curves. And it was just so beautiful to see that. So I could imagine some of Prometheus Materials' biocomposite material be used to create very organic looking buildings that absorb sound. I'm so excited for Prometheus and what they are going to enable because of the material that they're creating.
Just to build on that idea, I don't know that much about architecture or construction, and yet I follow new materials. And there is this trend right now where people are building skyscrapers from wood. And what they're creating are these wood composites. And actually in my neighborhood on Park Slope on Union Street, the first, I don't know if the first in New York City, but definitely the first in Brooklyn, as far as I know, first building that is all wood. It does have a brick facade, but the building is built of these timber composite. And all of that stuff gets constructed before it's brought on site. So the building is basically constructed in a bunch of pieces. Then they bring it on site and they construct it like Legos. I know it's more complicated, but as you mentioned, like Zaha Hadid, and thinking about the panels and the things that you could do with Prometheus material, I can imagine it being done the same in a similar way. You might be able to create these shapes that previously you weren't able to create because of the cement wouldn't allow you to do it. And so I'm very excited for that. I'm very excited to see how Prometheus material is applied. And just like I'm very excited to see how Biomason's bricks are used.
I did see yesterday, as I was scrolling on Instagram, I think. I forget sometimes what social media I'm on, but there was this very big 3D printer that was just like, quote unquote, the ink was cement. It was creating this beautiful building that is an organic shape. So there is like a machine that already exists that's spitting out cement to make these beautiful structures, whatever you design through software that the machine can just make. I'm sure they're just using regular cement, but wait till they get a load of Prometheus Materials and be able to use that.
There are people who are saying that kind of cement printing of houses is one of the things that can be used to solve the housing crisis, because you can build these very strong structures very quickly and easily, but you don't have to use cement. I don't think the Prometheus material is ready for that, because remember, he said that that kind of pourable cement is ready-crete. That's what we see in New York City all over the place when we see these cement trucks lining up to fill a building. And apparently that stuff has to be put in place very quickly because it dries very quickly. But I do know that perhaps that 3D printer is a way that material can be used. It's something we didn't ask him, and maybe that can be something we have in a follow-on conversation. The other thing I think of is last year in Amsterdam, or maybe 2 years ago, 3D printed metal bridge was put across one of the canals. And if you do a search for Amsterdam 3D printed bridge, you'll see this stunning organic looking bridge that apparently has a lot of sensors built into it so they could better understand like the traffic going across this canal. So I think the possibilities are tremendous, and I'm looking forward to seeing where this all goes. It gets me very excited about the things that are happening with biotechnology. Was there anything else? Because we're pretty busy with our work, and we may just need to sign off.
Yeah, we got a lot of opportunities thanks to all of our efforts and meeting a lot of people through Ferment. So we have a very busy schedule. But of course, we love making this podcast. We'll share a lot more information in the show notes. We always encourage you guys to check that out. Reach out to us. I mean, we love to hear from you. We'll give you a shout out. We'll take requests. And now I feel like a DJ from the radio. But yeah, anyway, so thanks, guys. Wait till you hear the next episode.
Thanks, and have a great week.